To simplify these radicals, again, we always need to have an eye on the index. If there's no number included, we need to assume that that index is 2. So we're looking for perfect square factors of 160. Well, when I look at 160, you might not think of anything immediately, but for me, the first thing I'm going to think of is that's 16 times 10. And I know 16 is a perfect square. 10 is not, but that's okay. I'm trying to eliminate perfect square factors from here and extract them or remove them from the radical. So the square root of 16 times 10 can be rewritten as the square root of 16 times the square root of 10. The square root of 16 factors into 4, or simplifies to 4. And the square root of 10, well, 10 doesn't have any perfect square factors. So it just comes out to be the square root of 10. I can't simplify this any further. In order to check this, I can take the number outside, 4, raise it to the power of the index, so 4 to the second power is 16, and then multiply by what's under the radical. 16 times 10 is 160. That's the original radicand. All right, we can take 4 squared is 16. The square root of 10 squared is 10. 16 times 10 is 160, and that's where we started. Here we have 5 times the square root of 16, and we're looking to simplify this. Well, the 5 is going to stay out front for now. And now let's re-express what's under here as a product of perfect squares if we can. Well, 16 is a perfect square. That's really 4 times 4. So because I have an index of 2, that means I need 2 factors underneath here to remove one of them. So this is really 5.4, or 5 times 4, which is 20. So 5 times the square root of 16 is 20, which makes sense. Because if you take 5 and you multiply by the square root of 16, which is 4, you're going to get 20. All right, so we can always simplify these by looking for perfect square factors. And if we have a whole number outside, then that perfect square factor comes out and is then multiplied by that number outside. All right. We'll do the same thing here. We have negative 3 times the square root of 50, so the negative 3 is going to stay out. We have the square root of 50. Let's break it down into perfect square factors. Well, that's 25 times 2. So this would be negative 3 times the square root of 25 times the square root of 2. So negative 3 times 5 times the square root of 2 would be negative 15 times the square root of 2. All right. So with each of these, the whole idea is to simplify what's underneath by looking for perfect square factors and listing them first. Once you've extracted all the perfect square factors, make sure that you keep multiplying by any number that you have out front. And then everything should add up. We should be able to check these as well. So in this one here, we had 5 times 4, 5 times the square root of 16, or 5 times 4 equaling 20. So we should be able to take 20 and raise it to the power of the index. So 20 times 20 would be 400. And if we took 5 squared, 5 times squared is 25. 25 times 16 is also 400. So this one works. And we do the same thing here. If we had negative 15 times the square root of 2, and we squared that, negative 15 times negative 15 is positive 225. The square root of 2 squared would be 2. 225 times 2 would be, would be 450. And if we take negative 3 squared, that would be 9. 9 times 50 would be 450. So all these check out as well.